Testing a perceptron. A perceptron must be tested and evaluated. A perceptron must be tested against real values. So we have to test perceptron against real values and we have to see how it behaves. Test your library, generate new unknown points, and check if your perceptron can guess the right answers. So we will create unknown points and check against those unknown points if it can be guessed by perceptron. Code snippet for the same is, so we are setting a counter of 500 and we will loop through this 500 times. X equal to a random value and y equal to a random value. Guess Petron dot activate against these two random values with perceptron bias. Let color equal to black. If guess is 0, then color is blue, and if guess is successful, the color will be black, and plot that point in the plotter. This is the code snippet for this particular activity, for this testing activity. However, in case we want to code entirely, we have to come here. Most of the code has already been discussed in previous videos. However, we are repeating this and we will add our current code on top of the existing code. So doc type HTML to scripts, then we have to assign 500 to these num points and learning rate is this. Now we have to create a plotter. Const plotter equal to new xy plotter my canvas. So we are creating a new object of plotter with name my canvas. Then plotter dot transform xy. We are setting the x max, y max values here and x mean, y mean values here. Create a random xy points. So we initialize here and then we enter 0 to num points. Num points is 500. So we enter 500 points. So we will iterate this I variable 500 times, and for each time we will enter a random value to x point and y point. Now we have to create this line. So for this we are creating this function fx, and in this fx we are returning x star 1.2 plus 50. This thing we already discussed earlier, how we create a line function. Plotter dot plot line x mean, f of x mean, x max, f of x max, and color black. That's how we plot the line. Compute desired answers. So we initialize the array desired I, and then we populate one element of desire I if y point is greater than fx point, and we set the value of desired I equal to 1. This is already discussed. Create a perceptron. So we create a perceptron object like this. Train the perceptron. We'll iterate through 0 to 10,000 and I equal to 0 to num points, and we train. This is also discussed earlier. This code snippet is new here. Const counter equal to 500, and for this number of counter 500 counter, we will iterate through each element of I, and these many times, these 500 times we will iterate x equal to math random into x max, y equal to math random into y max, and we will guess Perceptron dot activate x y. So these random values are entered as an argument here with the bias. Color equal to black. If guess is not correct, then it will be blue, and accordingly plotter dot plot point xy color flag is set here and here based on the outcome of the check, and that color is used as an argument for plot point, and that's how we get the output at the right hand side. Next, we have to count the errors. Add a counter to count the number of errors. Again, we have a counter 500, initialize error to 0, populate x and y with random value, then guess equal to Perceptron dot activate. Here again, we calculate the guess value, and based on the guess value that we have, we plot the point. Now here, if y is greater than fx and guess equal to 0, or y is less than fx and guess equal to 1, we count error plus plus. So all the errors that we are having is counted here, and it is counted against errors. Errors was initially 0. Each time this error is faced, the value of errors is increased by 1. That's why we get the value. For complete code, we come here. These are already known code. Same here. The new code is here. Test against the unknown data. So this is what we were discussing. If we get that, we will get the value as mentioned in right hand side. Here we see 28 errors out of 500. Why 500? 500 is the number of points, and this is measured against the counter. And how do we get 28? We get 28 by counting the number of errors. That is, the value of errors is 28. Next is tuning Perceptron. How can you tune the Perceptron? Here are some suggestions. Adjust the learning rate, increase the number of training data, increase the number of training iteration. So if we follow three conditions, then Perceptron will fetch better result and will be better tuned. That's all for today. Thank you.